Hello, Western Australian Year 12 Mathematics Application students, and welcome to this afternoon's webinar, the second in a series of 5 dynamic parcels of activities and ideas to helpfully move you on your way to your exam. My name is Brian Lannon, and I'm your host for the series, and the dulcet tones of my voice are now hopefully streaming beautifully through the audio system of your computer. However, if you do experience audio difficulties during the telecast, can I remind you that you can phone in on the toll-free number that is now on your screen. That number, 1-800-708-203. You will then be asked to enter the event number 827-825-279 and hit hash, and you should then be in. You actually don't need an attendee ID number at all, contrary to what was in a chat message. Now, can I suggest also that while you're viewing the webinar, you can maximise the presenter's shared screen by clicking on the double right arrow to the top right of the presenter's screen, and then at a later stage, to return to the WebEx features, you can either click on the pull-down tab that will most likely be at the top of your screen, or you can select the WebEx icon, which is a green and white ball that will most likely appear on your taskbar. Please also, can I encourage you very strongly to use the Q&A. That is why you're attending the webinar live. When you type in your questions, can you please direct the questions to all panelists? There are a group of us online ready to answer your questions. Can I also say thank you to those of you who have given us feedback following session 1 last Thursday afternoon. The pages, the tips, and the menu navigation that Hayley Daru walked you through has been very well received. Now tonight, we're going to work you a bit harder as the taskmaster, Mr. Crothers, takes you further into the course material. So get ready with your calculators. I know some of you may have already accessed the TI Inspire files from our shared Google Drive, but if you haven't, that is not a problem at all. Mr. Crothers, the taskmaster, will have you building them as we go along. So without further ado, I will hand over to the Jodstar 2000, the man who put the safety in Safety Bay in the applications in mathematics applications. Are you there, Jodstar 2000?
Yes, I am. Thank you very much, Brian. And welcome to
very
everyone
good.
in today's webinar. Okay, if you've got a chance, if you could just grab your handheld, the calculator, the TI Inspire. Once you've got that, we're going to take you through a series of processes and hopefully help you to be able to deal with some of the bivariate questions that you're sure to encounter in your final exams at school and in your WACE exams. Okay, first we're going to take you through setting up a bivariate data question. What to do on your calculator. Okay, I'm just going to minimize my PowerPoint and bring up a copy of the emulator so you can go along with me as I go through the questions. Okay.
Jodstar 2000, have you hit your share screen?
I'm about to hit the share screen. There's not a problem.
Fantastic.
Okay.
It's looking good.
Excellent. Here we are. Handheld this side, a copy of the screen, a bit larger on that side, so you can actually see the buttons I press as we go through. We've hit the exam. We've read a question. It's about bivariate data. We're going to have a new document because it's the first question we're going to answer. And we're going to develop what they call a list and spreadsheets page, or list and spreadsheets app. We're going to open up one of those. And it's really important when working with bivariate data that we name the list of value we're working with. So we can move using our controller up to that box there. This is where you actually name your variable. Now I could call it X, but the problem with that is there's a column called X. So we're never quite sure which one we're referring to. And we'll keep on getting questions. Are you referring to the variable or the column? So I should call it XVal for X value. Or move across And then I'm going to go Y value for the Y value. And they would be my default things that I use when I'm going through a question. When you answer a question in a little while, we'll actually tailor those values to the question, which will make the question even easier to solve. But it's always important when working with the statistics to name the columns and name the lists of values that you are working with. The other thing you need to realise is the handheld will produce a huge variety of statistics. The two relevant to bivariate data are the one called two-variable statistics, which is great, and the other one is linear regression. There's actually two linear regressions, y equals mx plus b, or y equals a plus bx. Both of them give you a lot of information, but you need to choose which one you're going to use, or you can use both if required. Now, we take a quick look here. I'll blow this up to be the whole page so you can have a look. In the middle is the screen that I would use. The X list in this case I called minutes, and the Y list concentration, and you'll see why we answer the question. If we use our two-variable statistics, we generate all this data to the left. N, the mean of Y, the sum of Y squared, the variance, the standard deviation of a sample, a whole set of values, the correlation coefficients in there, medians, maxes, interquartile ranges. For some questions, they're the ones you're going to need to use. For other ones, it's the linear regression, which appears to give you less data, but it's more specific to the type of question. The question we're going to answer today will be using the linear regression. So, we've got title, linear regression. The form, the equation is M, B, the determinant of coefficient of determination, and the correlation coefficient, and a bit about a list of residuals. The easiest way for us to do that is to actually go through and have you answer a question. Here's a question from a sample exam paper. It's been conjectured that the longest one drives on country roads, the concentration of the driver lessens. So a suitable test was devised, a study was done, and they've come up with this table of data. So I'll give you a clearer view of that data table here, and I'll bring back my calculator. And at this point, I want you to do some of the work. So I'm going to go across to A and call it minute, or minutes, let's be grammatically correct, and conc, the concentration. Now, some people like, every time you enter data points, I'll enter 72, hit return, it moves down. Some people prefer to enter the lists straight down and then do the second list, and that's fine. So we'll go through and we'll do that. We've got 72, 73. So if you've got your handheld there, please go through, create a list of spreadsheets page, name them min and conc, minutes and conc, and work your way down entering the data. The reason I'm getting you to do this is all of us can enter data onto the handheld, but what you need to do is remembering in the exam situation, you need to be relatively speedy and completely accurate. Because if you get one data point wrong, you're going to have a whole set of problems. So I've done one column, now I'm going through and doing the second. Try not to type too heavily. You can probably hear my typing away on the calculator, and that's fine. son has purchased a gaming calculator, gaming keyboard, which seems to be a lot noisier than the one we previously had. Wonderful. I'll check, making sure the pairs of data match up. As the tradesmen say, measure twice, cut once. So check your data a couple of times before you actually go and do your calculations. It's really a point and will save you a whole lot of heartache. In a classroom situation, you get something wrong, you can show the teacher, they can correct and say, oh, you've got this piece of data wrong, that's why your answers are out. In an exam situation, you don't have that luxury, especially when you hit the end of the year, the WACE one, you'll have no idea whether you've made a little mistake or not, and it can make it more difficult for the markers to work through. Okay, so what I'm going to do now is I'm going to encourage people, if you've actually completed the data, entering the data, if you could go to the chat or the Q&A and just say, data's been typed in. And I'll let Brian inform me, because I can't actually see the chat while I'm presenting, when somebody's finished the data. Once a couple of you have finished entering the data, or if you're not going to enter the data right, complete anyway, make me think that you've actually done it, then I'll be in a position to go on and take you through. So while we're entering the data, I've just got a quick joke. I'm putting it in the middle.
That's good.
Lost in a balloon. It's flying over a plane. Doesn't know where he is. He's in a hot air balloon flying across. And he's with a couple of mates going, oh no, we're lost. And he sees someone standing on a hill and yells out to the guy standing on the hill, where are we? And the guy looks up and goes, you're in a balloon. And the guy in the balloon looks at his mate and says, it must be a mathematician. His answer was completely correct, but totally useless. Now, Brian, are we getting any feedback about people having completed entering data?
I've got a couple there. GH is in and SL is in. And I haven't heard from others yet, but we know we do have many more online. And I'm also waiting to see the keyboard light up with LOL in response to your joke. I'm waiting to see it. No lols yet, though, Jodstar. Sorry about that.
You may be waiting a while.
Oh, I can see there's more that's come through in the Q&A. We've got KW is in, MD is in, and MD's also commenting on your joke, saying he hopes it's better than last week's. He's having a go at mine, and his follow-up comment was, no, it wasn't. So there you go. Your jokes are as bad as mine, mate.
Okay, not a problem. So let's take it from here. We've got our two sets of data. Now in the question, they've actually got the graph of the points and a line of best fit already put in. But I'm going to do that ourselves. So I'm going to go Control-I. So Control and I, which creates a new page. And the one I want to create now is Data and Statistics. And this gives us lots of lovely dots all over the place. If we move down to the bottom, we're going to choose our minutes. And then we move across to the side, and I'm going to choose our conc for concentration. And there's our lovely set of data. Now the first part is we're being asked to estimate a correlation coefficient and explain our estimate. Looking at that, first thing I can say is it appears to be negative. So the value is going to be negative. It's not a perfect linear relationship, so it's not -1, but it's pretty strong. So I'm going to say it's going to be about 0.8, 0.7. I wouldn't go to more than one decimal place. So 0.7, 0.8, based on it's strong, it's negative, and they're pretty well grouped. So that would be my estimate. So when we get to marking it, let's try and remember that I was completely correct. Now we're going to calculate the correlation coefficient, R. So we go back to...
That sounded more like a pirate R to me.
That's correct. 1.1. So here's where the power of the handheld becomes evident. We can press menu, statistics, stat calculations. And as we discussed before, we're going to use linear regression for this one. So MX plus B. Click there. And at one wonderful table. Here's where the importance of naming a list becomes. We move across, click on there, we choose minutes for our X value, and we choose concentration for our Y value. Noting, when we do this, that our regression equation is going to be F1. That's going to be important in a couple of minutes' time. So I would write that down on my piece of paper, F1 for the regression equation. And that's fine. And it's saying results in column B. Well, I don't want the results in column B because that's actually going to go over the data I've already got. So I want my results in column C. I can have it C, D, E, F. So we'll go column C, and I'll go OK. And here's our information. Now, if you just finished entering data points and you do this, often you won't see the answers and you'll be a bit concerned. You need to make sure you scroll back up, and here's the information. We've got our gradient line regression, our y-intercept, R squared, and here's R. That's what we're looking for, the correlation coefficient. So the answer to that one is minus 0.68. Wonderful. We've just got a couple of marks just by knowing how to use a calculator. Now, the next question is explain why there is 54% of unexplained variance. People go, I don't see 54% anywhere. But what I do see here, with a determinant of correlation, is 0.46. So I'm going to copy that value. I'm going to create another page, calculator page, and I'm going to go Control V. So that's our R squared, determinant of correlation. So what that tells us is that 46% of the variation of our Y value comes from our changes in X values. Now this is an interesting concept. It's the first time it's appeared in the West Australian curriculum, the use of R squared. So this is telling us how much is explained variance. So if we go 1, take that number, 0.534, that's about 54%. If we really want, we can times it by 100. There we go. So 54% of unexplained variation is because 46% is explained to the determinant of correlation. So you have that calculation, 1 take 0.46 equals 0.54, and that would explain it why, because we've got so much that is explained, leaving 54%. That's unexplained. Okay. Now, next question. Explain the relationship between the sign of the correlation coefficient and the gradient of the trend line shown on the graph. So we'll go back, and our correlation coefficient is correlation coefficient is minus 0.67. So when we talk about our relationship, it means it's a negative relationship. By negative, it means as X increases, Y decreases. I've just spotted typo in my questions. There. Both. So the negative sign means that as the X variable is increasing, the Y variable is decreasing. So it's negative trend. Determine the equation of the regression line. We can simply write Y equals negative 0.86 plus X plus 102 if we want. Or back on our calculator page, we can go F1, which we knew our regression equation of X, and it can put us in that form too. Either way, it's perfectly correct. It's not a problem. having it as the y-intercept first with the gradient, or the gradient first and the y-intercept. So mx plus b or a plus bx, there's not a problem either way. They're both exactly the line of regression, which is useful. Now we know our line of regression. We can use that to estimate some other scores. We've got the concentration scores and comment on the reliability of your estimate. Okay, so the first one is after 74 minutes of driving. That's great. After 74 minutes of driving, our concentration level is 38.6. Well, our correlation, as we saw before, is moderately strong, negative 0.68. So it's reasonably reliable. It's interpolation, so 74 is within our data set. Having a look at our data set, 73, 75, so it fits within our data set. So we can be safe that the 74, our estimate is going to be 38.6, might even be 39. See, we seem to be dealing with whole numbers. We can give it back as a whole number with no decimal places, that's fine. And say it's reasonably reliable due to a moderately strong correlation coefficient and interpolation. Now the next one. Next one's got a trick or two to it. F1, an hour and 3/4. Now you can't type in 175 or 1.75 or anything like that. So you've got to go hour is 60 minutes, 3/4 of an hour is 45. So you have to actually add two things up. So 60 plus 45, 105. Wonderful. After driving for 105 minutes, using our line of regression, we worked out our concentration is 12. That's good. So we can put that down as our estimate. But we're going to find our estimate. We need to go back. It's still got the same correlation coefficient as the first one. So on the basis of that, we think it might be reliable. But we go back and look at our original data, and our original data goes up to 88. This question's asking for 105. This value is extrapolation, and it's extrapolated well out of our set of data. So it's really important at this point to realise that it's going to be unreliable due to the extrapolation. And this can be highlighted too. It's not the question. So if I actually drive for 2 hours, 120 minutes, I have negative concentration. I'm not quite sure what negative concentration would be. Maybe it's sleep. This is demonstrating the further you go away, the more you realise why the data might actually be unreliable. So, for 105, we can estimate it's going to be about 12, but we realise that that's going to be an unreliable answer. Wonderful. So we've gone through, we've had a look at the answer to that question. Pull down here. So the first one was, here's the marking key we're going to look at. Minus 0.8, we estimated. I estimated 0.7 because I'm pretty good. And guess what? It turned out to be minus 0.7. R squared was 4.6, one take 4.6, 54%. That's where it's come from. They said there's an inverse relationship between the minutes driving and concentration level. As the number of minutes driving increases, the concentration decreases. The slope is negative. The correlation coefficient is a measure of this relationship. It's also negative. That's good. Line of best fit. 74, 105. So they've got 39 and 12, which is the same as our estimates. 74 within the data range, prediction is reliable. 105 not within the data range, so the prediction is not reliable. Well done. I think I got 100% for that question. Good on me.
Done well.
I think I've done very well. Now, back to the PowerPoint. There's the question. If you want to have a look at that question will be in the Google Drive, all questions. And we got thanks to Margaret Denham, who writes exams and has written WACE exams previously, who's let us use some of her questions, which is great. I'm going to hand over to Brian for a couple of minutes so he can take you through just some basics about the correlation coefficient and the R squared, the coefficient of determination, and the like. Thanks, Brian.
Thanks, Johnstar. And I think that was a really good example there, that one. And something that students might want to do, now that they've built that into their calculator, you can actually save that file, give it a name, and during your exam, if you get a question similar to this, obviously in part B of the exam, if you get a question similar to this, it's as simple as opening up that file and then modifying the data. So this one I'm just starting to build, but here is one that I did before, working through Jodie's examples here, and I've got a scatter plot of the data with the equation and the coefficient of determination. But if the data were different, if I had a different set of data, then I can just type it. Let's say it's not minutes, let's say it's, I don't know, height. And let's say it's weight. Or I can just leave it as the two things. So I'm going to go back into minutes because that variable is already there. But it could represent the different things, and I could have different numbers here. And you can see it's just a matter of editing this. As long as I have the same number of data points, although if there's not, I can type more in, or I can delete some. As long as for bivariate data it matches up in the two lists, then when I go to the regression, if I run that command again, I'll get the new model, the new regression model, and the new data, the new equation, the new coefficient of determination. So once you've got this built, then all that calculation is there, and I've also got a copy of the residual plot. So all of that is there in this file. All I need to do is change page 1.1 for the different data. You can call this, rather than minutes and concentration, you could call it X var, Y var if you prefer, or independent, dependent for the two variables. But Jodie, while we're working there, I started it again and I typed it all into a new calculator lists and spreadsheets page, and I see that you did your calculations, your stats calculations within the lists and spreadsheets page. I'm going to do it slightly differently than that. I'm going to actually put in a calculator page, and on the calculator page, if I hit menu and go to statistics, statistical calculations, and I'll do a linear regression. Now, somebody did ask, which model do we choose, MX plus B or A plus BX? Essentially, it's the same thing, just spelt differently. Traditionally, in our introduction in mathematics courses, we've generally used linear functions as being y equals mx plus b or y equals mx plus c, where m is the gradient or the slope. That's a very, very important point to keep in mind. M talks about the rate of change of the x variable, okay, the rate of change of the y variable with responding to the x variable. So it's the rate of change. As one variable changes, the other changes in response. The independent term, whether you call it B or C or even A as it is here, that's where if you extended the line, it would intercept the y-axis or the vertical axis. So that's the two important things, coefficient of the x and the independent term. I'm going to go with mx plus b. Traditionally, statisticians tend to prefer using the a plus bx, but I like the mx plus b. And I'm going to put in the X list because I labelled them in the lists and spreadsheets. They're now remembered as variables in this document. So minutes in the X list, concentration in the Y. As Jodie showed you, the equation, the regression equation will be stored into F1, and I'm just going to count each data point once. So I just leave all these other things, say it's okay, and there it is. That will change, as you saw, if I change the data, but if I do that, I have to rerun the command by arrowing up and hitting enter and running the command again. The other thing I like to do is to, well, now that that F1 is stored, I'll just show you something. If I go to a normal graphs page and graph the F1, there's the equation. It's been stored into the first function on a graphs page. If I tick this, it will graph it. It's not ticking for me. I'm going to make this one here. Was it F1 of X? And it's there, but I just can't see it because of the scaling of the page. So I'm just going to change the zooming on that, and I might just go for a zoom fit, and there it is. There's my formula. So it is there, and it can be stored in a graphs page, but it makes much more sense to view this in a data and statistics page. So there are all our data points, and if I click here, I add the variable. Now, there's a lot more variables now because once we do the regression, things called statistics residuals and statistics XReg and so forth, they're all created by that regression process. I'm going to put minutes on the horizontal or X or independent axis, whichever you call it. Some people call it the explanatory variable. On the other axis, I'm going to put concentration. On the y-axis, the vertical axis, the dependent variable or the response variable. And so there are our data points. We look for the general trend. And before I put a regression equation in, I'm going to do something else. I'm going to just put in by analysing, I'm going to put in not that one. Before I analyse in regression, I'll add a movable line. So a line has just simply appeared on this. Here's the equation to the line. M1X, M is standing for model. So the model for this relationship at the moment is 1.56, etc. X minus 90. It's not a very good model at the moment, but if I move it around, you can see I get it. That looks a little bit better, and you can see the equation there. It's not what we had before. It's not the best equation. Can we get better? If I hit menu and show, I'll just look where this is at the moment. I'm going to do a control menu, and nope, not there. Nope. I'm wanting to show squares. Jodstar, where have I left that behind?
It's there. What you're trying to do? Visual?
Yeah, showing the squares. I'm lost on my menus now. This is where we need Haley, the menu expert, to show us.
Analyze 7 residuals. You're just about there. Under regression.
There we go. Thank you. Show residual squares. And so the sum of the squares at this stage is 303.5 and a bit. Now, obviously, I want that to be as small as possible. So if I move my regression line, I can try to make it as small as possible, because what's happening, if I simply measured the distance from the data point to the line, some would be above the line and some below, and so I'd be counting some positives and some negatives. So that's why, and of course the negatives might balance out the positives. So that's why we square them. Squaring is a mathematical trick of making everything positive. So that's what's happened there. So I've got a sum of squares of 287 and a bit, and there's our model. It's not necessarily the best. Let's analyse and this time do the regression and do the linear regression, and there it is, and you can see that's different from my model. It's a different equation, and I could also, And another trick I can do there, not on that one, on this one, another trick I can do is I can get the coefficient of determination value to pop up by clicking in here in the settings. If I click here on diagnostics, I get my R-squared value. So there's the two things there. I'm just going to jump back to the JodStar PowerPoint.
Yep, that's great, Brian.
The other thing to talk about there, of course, is this, and you will be asked this in your exam, is to make comment to the strength, the direction, and the type of the relationship between the variables. And can I encourage you, use the names of the variables. So in your answer to this, you talk about concentration and minutes driving. So you would say that the strength is, you can say positive, you would say either weak or moderate or strong. So you'd use one of those terms, and based on how tightly it fits and how close to 1 your R-squared value is. So moderate, so weak, moderate or strong. You then talk about the direction, positive or negative. Now, if you just do an R value, so R being the coefficient of the correlation coefficient, the correlation coefficient runs from -1 to +1. -1 would represent a perfect negative straight line. So it's a straight line with a negative slope. +1 would represent a straight line where when one variable increases, the other variable increases. And 0, there's no apparent relationship at all. So talk about the strength, then the direction, positive or negative, and then the type. So the type, because we've put a linear model on this, if the linear model looks good, then it will be a linear relationship. Alternatively, there may be other types of relationships. It might be quadratic, it could be exponential, logarithmic, other sorts of weird things. But generally, if the linear model is looking fairly good, then that's what you'd run with. You'd say it's a linear relationship. Now, a very handy way of seeing that is to actually plot the residuals. So I'm going to put in another data and stats page, and this time I'm going to put the minutes, and I'm going to put the residuals up here. So this is basically saying how far away from the line each of those data points were. So this data point here was pretty close to our linear model. These ones are getting further away. So for a good match, I'm wanting these to be reasonably tight to the line, but also to represent a linear model. I'm wanting basically a rough, a fairly random scattering of the residuals. If I see a pattern here, like if I might see a parabola, then it's possibly an indication, or I might see a straight line coming through here, then that would be an indication that my linear model wasn't the best model to use. So that's what happens with a residual plot.
Great. That's great, Brian. Do you want me to pick it up from here and we'll try and get through another question before the end of the session?
Yes, let's do. We've talked about these ones on the slides. We've done that. Correlation and causation. What's happening there, Jody?
Well, flip it across to me and I'll talk through it.
I will do that. Yep. So we could have good correlation. So does that mean that one thing is causing the other?
I would hope not all the time.
It could, not all the time. There we have the same slide from a different computer.
Good.
On the other side of the
not being causation. And it talks about causal relationships in scars as dot points, not casual relationships as some of my year 12 might describe them. And a good example of this that I like to use is the number of firefighters who attend a fire has a strong positive linear relationship with the amount of damage that's done. And that does not mean the firefighters cause the damage. The reality is there's a common response to another variable, which is, in this case, the size of a fire. So it's having a look at those extreme examples. and realising there can be a strong relationship, but it does not mean causation. All this data work we do does not prove causation. It just proves there is the amount of relationship between the variables. That brings us across, next one, to the coefficient of determination. It's got R2 there. It should be R squared. And that'll appear in the linear regression. R squared is interpreted as representing the percentage of variation in the dependent variable explains the variation in independent. That doesn't mean much. What it means is when you change X, you get a Y value. So how much in the change of Y is because of X? That's determined by the coefficient of determination. And we did that in the last one, where 46% of the change was determined by the change of X, the change of Y, and the rest was unexplained variation. And that's new to the West Australian syllabus and the course of the conversation. So your teacher may not have seen that before, but that's where it's coming from. So often it'll be looking at the amount of variation explained by the change in X and the rest becoming unexplained. And here are those syllabus points I was talking about. Recognise an observation between two variables does not necessarily mean there's a causal relationship. And identify possible non-causal explanations for an association. Coincidence, common response to another variable. So that's the sort of language you should be using, because that's the language SCARS is using with us. And just another reminder that extrapolation is unreliable. It talks about distinguish between interpolation and extrapolation and recognise the potential dangers of extrapolation. So we're going to do one more question. Here's how to answer a question. And this applies to just about every question in the exam. And if you're lucky enough or unfortunate enough to ever be in one of my classes, I talk about this all the time. 1, you need to read the question. You need to, so you understand what they're actually asking you to do. 2, you do the maths. 3, you answer the question. A lot of my best students will do wonderful maths and actually fail to actually answer the question that was asked at the beginning. So now it's your turn.
I'm just thinking, Jody, could I add to that?
Yep.
I tend to think the last step is to read the question again to see that you actually have answered it.
That's a good strategy in helping you to answer the question.
Yeah.
Wonderful. Now it's your turn again. I've got a wonderful class, Mr. Joestar, awesome applications class. They've set 3 tests, and we've got data for every test for 6 of the kids, and poor old Angela, who got sick suddenly before the last test. We need to extrapolate or interpolate or determine a mark that she may have got for test 3. So we've got 3 sets of data in this case. So we're going to need to bring up our Handheld again. You can either start a new document, which for me, I like starting a new document. Some people like new problems. I will start a new document. Yes, I'll save those changes, which is wonderful. List and spreadsheets. And I'm going to call this Test 1, Test 2, Test 3. It won't let you leave gaps between your variable names. Now, if you get your Handheld, just take a couple of minutes to put in the data. 25, 38, 47, 56.
23, 46.
63, 82, 75, 60, 65.
Oh. 87 down the bottom there.
Missed one. Need
Yep.
to check. 54, 89.
77 before the 89. 92, 65, 84.
Wonderful. So I've got the 3 tests in here. So I'm going to swap to another version, which the data's a bit smaller, but you can see most of my data there. And we're going looking at the table. which test appears to be a better predictor of the test 3 results, and justify your answer. The biggest key with this is the justification. So one of my students yesterday said, test 3, because the test 3 scores seem to be about the same sort of size as test 2 scores, so that would be the best prediction because the scores are a similar sort of size. And that was his justification, which is fine. He had an answer, he's justified it. Now, part B, which results have a stronger correlation? Test 1 and test 3, or test 2 and test 3? So, I'm going to go menu, statistics, stat calculations. I'm going to do the linear regression for test 1 and test 3 to start with. That's going to be in column E. So for test 1 and test 3, so looking at the first column and the last column, correlation coefficient for that is 0.99 rounded. That's huge. So I've got that down as a value. And then I'm going to do the same thing for the next set, data statistics, stat calculations, linear regression for test 2 and test 3. Oh, and remembering that F2 is for this one, F1 was for the previous one, the equation. So I'm going to go there, and I'm going to put that in column G. Or I might actually go across and do it in H. I want to give myself a little bit more space. So, if I go up the top, it actually tells me it's for test 2 and test 3. And the correlation coefficient of that is 0.24. So it turns out the relationship between test 1 and test 3 is stronger than the relationship between test 2 and test 3, which for my students was a surprise. For me, it was no surprise because I wrote the question this way. So determine the lines of regression. Well, that's pretty straightforward because we've got our M value here and our B value, and our M value and our B value. But if I go to a calculator page, Control I know F1 of X was our first one. There it is. F2 of X was our second one. So here are our two equations. So we know we've got test 1, test 3, test 2 and test 3, the correlation, and we realise the first one's stronger, very strong. We've got the lines of regression for both, which is great. Now, given that Angela scored 54 in test 1 and 65 in test 2, we're going to use our lines of regression to predict the test score for test 3. So, for test 1, which is F1, test 1, test 3, she scored 54. 92%. Well done, Angela. And for the next one, F2, S2, she scored 65. So we put that in our second line of regression, 77%. Yesterday I asked Angela which you prefer. She told me the first one. And I said that's fine, because that actually has the strongest correlation, which keeps her the most appropriate mark. So we comment on reliability. The reliability of the first one is very high reliability due to a positive, it's interpolation, and there's a very strong correlation coefficient. The second one, while it's interpolation still, very weak relationship. Therefore, the first one is more reliable, and that's the one I would use in this case.
Great question. I must admit, Jody, that when I first looked at it, when you sent the notes through, on just looking at the data, I thought, yes, test 2 initially, but then when I crunched the numbers, I got the same conclusion that you did, test 1.
Yeah. So it gives you a chance to have a look, and while you could do two things, you could go back to part A and change it if you wanted, but I actually quite like the fact that someone's looked at it, come up with a reason, justified the reason. They would still get full marks because they haven't done any calculations at this stage, and turns out they were wrong.
Yeah. As long as they've presented some sort of reason for for justifying their initial punt.
And that's
their
right.
Initial idea. Yep.
So that's good. And that question will be up and available in the Google Drive as well. So that's all for me for now. Now, if you've got any questions, make sure that keep on putting them through the Q&A. And if not, I have no more jokes for this session. If you have any friends who are doing the course, encourage them to watch this week's video via YouTube. It should be up tomorrow or the day after. They've been very good with the turnaround. They may have more difficulty editing out my joke. And sign up. Sign up for next week so they can get the emails and know what's happening. Thanks very much for attending. I'll hand it back to Brian.
Thanks, Jodstar. And there he is, with Jody's Twitter information there as well, Jodstar2000. And please follow up with when you get the follow-up email, please go to the Google Drive, because the documents and files that the presenters have been preparing, I think, are very useful. And the more of this you can get, particularly transferred to your calculator in preparation to take into your exam, I think the better equipped you're going to be at that time. Let us know if you're having any difficulty accessing the Google Drive. It's all sorted into folders of week 1, week 2, week 3, and you can actually access any of those weeks once you're in there. And stay tuned for next Thursday, when we will be looking at sequences, recursion, growth, and decay. But for this evening, for this afternoon, thank you for attending. All the very best, and see you next week. Thank you, Jodstar.
Bye.
Cheers.